Okay, so when we think of connective tissues, we have to think of it like a jello mold. Did you know that there's a jello museum in Leroy, New York? Moving on. When you make a jello mold like this one, with the fruits suspended in the jello, we can make a crude but useful analogy to connective tissues. All of our connective tissues have cells. And we're familiar with cells and their nuclei from looking at things like simple cuboidal cells with the nucleus right in the center. The cells in connective tissue they're various, and we can have things like mast cells, fibroblasts, osteocytes, all cells that we will slowly get to know. But this is like a jello mold here with different kinds of fruits in it. The fruits are like these specialized cells suspended in the gelatin. But what's in the gelatin? If you've ever made a jello packet, you know that it's just water and jello. The jello mix is really just soluble proteins, like horse hoof. Just kidding. Actually, I'm not. But these proteins, they suck up the water and they harden into a gelatin. This is the same thing as the goo in which your specialized cells are suspended in connective tissues. Aside from the specialized cells in a connective tissue, which that is one of the three main components in any connective tissue, aside from the cells, there are proteins like the proteins in gelatin. In a connective tissue, we have only three types of proteins: collagen, reticular, and elastic. Whereas epithelial tissue was classified by the shape of the cells, connective tissue is classified by the amount of each of these fibers it contains. We're going to call these proteins fibers. There's one more component of a connective tissue, and that's the goo, or the water, in which the jello proteins are dissolved. In our jello mold analogy, the water would be what is called the ground substance of a connective tissue. It's like the background goo. Sometimes, though, this doesn't have to be gooey or watery. Sometimes it can be a hardened substance like bone. When we consider tissues from here on out, we're going to use this term matrix. This term combines the protein fibers and the ground substance and lets us think of a connective tissue as specialized cells and then the background substance in which the cells are suspended. So you're going to see this term, matrix, and I want you to be aware that it refers to both the ground substance and the fibers together. That jello mold kind of looks gross. Before we even get started, let's make a realization. None of these pictures here have a lumen or an open space. Nope, the middle one doesn't. Sorry. So, no, there's no lumen. Correct. The epithelial tissues that we previously covered, they lined an open space. But these connective tissues, they're like packing material or filler. And so there's no open space. Connective tissues can be divided into two categories, making it a little bit easier for us to conquer them. The first category is loose connective tissue. I think that when students hear this title, they think that loose applies to how the cells are either packed in or spread apart, right? Loose or packed. Untrue. The term loose applies to how the fibers, like collagen, reticular, and elastic fibers, are distributed throughout the tissue. In loose connective tissue, the fibers are not pushed up against each other. They form a loose network that suspends cells in the surrounding goo. Look at these pictures on the left and the right. You can see the protein fibers as lines, and they're not pushed up against each other. They're spread apart, forming a network. The picture in the center You know what? Just try. It has protein fibers, kind of. You can't see them. I also want to point out right now that one connective tissue does not have to have all three fibers in it. So the three loose connective tissues are areolar, adipose, and reticular. And we're going to look at them in a little bit more detail. Every book I have ever taught from uses areolar tissue as the perfect example of a connective tissue because you can get a picture of areolar and you can just label a whole bunch of things in it. But let's remember, though, that the term loose connective tissue is referring to the arrangement of the protein fibers. So let's look at the protein fibers in areolar. It contains all three that could be found in a connective tissue. Students usually connect or find familiar the term collagen, which is this large protein that sucks up water and is present in the dermis of your skin. Collagen stains pink, and at certain magnifications, it can have a very thick look to the fiber. So these big, large lines of pink, these are all collagen. It's difficult to tell reticular and elastic fibers apart, and I'm not going to ask you to do that. There are so many cells that could be found in areolar tissue, and this is because areolar tissue is like general use packing material in your body. Therefore, it's found everywhere, and it could have different cells in it depending on where it's found. I like this picture at the top right. It's really kind of awesome. It's what's called a mast cell, which is the cell that contains histamine. The most common type of cell that you see in areolar tissue, though, is a fibrocyte. And that what it's doing is maintaining the integrity or the structure of the fibers and the matrix in general. There are fibroblasts, and they're creating the fibers. In most pictures like this, though, you can't tell the difference between the two. However, learning about fibroblasts and fibrocytes gives us an important lesson into the suffix of these two words. The suffix blast comes from a term meaning to create. The suffix cyte, it just means cell, but usually we see that cyte, it's just a common name for cells in a tissue. We look at reticular tissue here because it is a great example of connective tissue, but we're never going to see it again until we get into the lymphatic system, which is next semester. Reticular tissue is found in lymph nodes and other lymph organs like your spleen. What you see in these pictures are B cells. Those are the red B cells. They're a type of lymphocyte, which is a type of white blood cell. And all of these lymphocytes are suspended in a network of reticular fibers, which are the black lines in the picture. It's nice to cover reticular after we talk about areolar because it reminds you that a connective tissue doesn't have to have all three fibers in it. As indicated by the name, reticular has reticular fibers. This picture reminds me of cherry tree blossoms. I don't know. There's just some tissues that remind me of something in nature or in my life. I urge you to make those connections. I also want to point out that I'm showing you these pictures at different magnifications. Look at how the picture on the left of the slide and those in the middle are magnified a little bit differently. But each of them still shows the characteristic look of reticular tissue. Adipose tissue is definitely a tissue that you should get to know, and you will. I had a student many semesters ago who came in with printouts of Google searches for the different tissues. And I realized that this was great because she had multiple pictures of the same tissue, and it forced her to realize what was similar among those pictures. I encourage you to do the same thing. Sometimes just doing a Google search and looking at all of the images, it could be really helpful. Adipose tissue is confusing for students because they sometimes think that these open spaces are lumina or singular lumen. Yeah, I know, but we just have to get to know adipose. It's everywhere. The cells in adipose are very tightly packed together. And remember that the term loose connective tissue refers to the fibers, not the cells. The cells in adipose tissue are big, fat, and round. And that open, clear space that you see in the center is an oil droplet that doesn't like to take the pinkish purplish stain. In fact, these cells are called adipocytes. And they're so intent on storing a big oil droplet that they push that darkly stained nucleus off to the side. For me, some of the pictures of the adipose tissue, they look like a diamond ring a little bit. I don't know. Or like the nucleus on the diamond is sitting on top of a ring. I don't know. It's a stretch. We know some obvious places where adipose is found, like the buttocks and the abdomen, but adipose it's really good at cushioning, and therefore it can protect really important organs. You have adipose deposits around your kidneys and around your eyes.